Today's video will demonstrate how to classify the alignment level of a class design. Hello, I'm James Helfrich. There are three metrics for the quality of a class relation design. One of these is alignment. Alignment describes how well the design maps to the problem domain. In other words, will the subject matter expert recognize all aspects of the class design? This video will demonstrate not only how to classify the levels of alignment, but also define what alignment means. Alignment is the degree in which the inheritance tree models relationships in the problem domain. The phrase problem domain means the things in the real world that the software is meant to do. In other words, all software models something, and the problem domain is what we're trying to model. Now we have complete alignment. The problem domain and the inheritance tree match. In other words, every element the subject matter expert can think of has a corresponding element in the inheritance tree and vice versa. Extraneous means you might have an extra base class or an extra class that is not in the problem domain. Partial means that there are missing constructs, but nothing is extra. In other words, part of the problem domain is not modeled. And poor means it's both partial and extraneous. We poorly represent the design concern. So let's talk about complete alignment. Imagine this concept map provided by the subject matter expert. There are several different types of lists: an inventory list, a timeline list, a checklist, and an order list. And on the order list, there are favorite movies. Now notice this class diagram. We have a list of the base class, which corresponds to the center of our concept map. And there's four different categories corresponding to the four different things leading out of the list in the concept map, and so on. Since every single class in the class diagram maps to an element on the concept map and vice versa, we have complete alignment. Now, extraneous alignment occurs when the problem domain is completely modeled, but there are extra classes. Usually we do this for performance reasons, we do it for adaptability reasons or whatever. There is often good reasons to have extraneous alignment. However, when there are elements in the inheritance tree that the subject matter expert would not recognize, then we have extraneous. And so for an example, I may decide that the semi-order list, we have a checklist and an inventory list, and the subject matter expert did not mention those explicitly. However, they do make it easier for me to write the code, so I have less redundancy. Okay, let's take a look at this example. A financial program needs to model several types of users: those who have access to the system and those who are simply external contacts. Those who have access are subdivided between observers, users, administrators, and auditors. Now let's take a look at our class diagram. We have people, we have visitors, we have employees, external users, observers, alumni, and auditors. Now this is poor alignment because we have aspects of the problem domain which are not modeled in my class diagram, as well as we have access elements in our class diagram which are not part of our problem domain. And because the two do not align carefully, we have poor alignment. Here's another example. A bank offers several types of accounts: loans, cash accounts, and credit cards. There's currently one type of loan, auto, but the bank will offer more in the future. There are two types of cash accounts, checking and saving, and currently one credit card, Visa. Let's take a look at our class diagram. We have three types of accounts: auto loan, cash, and Visa. And we have two types of cash accounts, checking and savings. This is partial. Every single class in the design is representing the problem domain. This means we are at least partial or complete. However, there are several items in the problem domain that are mentioned but not part of the class diagram: a loan and a credit card, for example. This makes this design partial or poor. Now, since we're partial or poor and partial or complete, therefore we are partial. Here's a third example. A financial program needs to display several types of reports representing account activity: a histogram of account balances over time, a histogram of cash flow over time, a ledger of balances, a pie chart displaying how much money is spent. Interviews with a subject matter expert suggest that each of these reports are distinct. Now, notice our class diagram. We have ledger, balance, cash flow, and pie chart, but we group them under histogram. Now, this is extraneous because every element in the problem domain has a corresponding element in the class diagram. However, the subject matter expert did not mention notes of a histogram. Now, it kind of makes sense because both balance and cash flow are types of histograms. However, the subject matter expert did not mention that, therefore we're extraneous. And our final example: A financial program has a notion of a transaction. This can be either a withdrawal or a deposit. A withdrawal can be a cash withdrawal, a check, or a transfer to another account, or a credit card transaction. A deposit can be a bank deposit, interest earned, or transfer from another account. Now, notice how we both have the transaction has both deposit and withdrawal, and the deposit has the 3 types of deposits, and the withdrawal has the 4 types of withdrawals. And this is complete because both the overall names of the various accounts is represented and the main classifications are represented as well. Since every element of the class diagram maps to the problem domain and vice versa, we have complete alignment. This is example 32.1, 32.2, 32.3, 32.4 in the alignment chapter of the software design textbook.